今天我想和大家聊聊微软最近在 Build 2025大会上放出的重磅信息。这次大会最核心的一个新概念就是开放的 Agentic Web，它可能预示着一个堪比当年 Web 或者移动互联网兴起时的重大转变。而理解这个概念的关键，除了去看微软的完整视频，我们也可以从行业巨头的对话中快速了解它。微软 CEO 萨提亚·纳德拉与 OpenAI 的山姆·奥特曼、XAI 的埃隆·马斯克以及英伟达的黄仁勋，在 Build 2025大会上进行了现场连线对话。他们的对话勾勒出 Agentic Web 的未来图景。那么，什么是 Agentic Web 呢？简单来说，我们可能正在从与一个个孤立 App 打交道，转向一个由无数智能体构成的网络。微软特别强调，这个网络是开放的、可扩展的。这些智能体未来可能会无处不在，主动帮我们处理各种事务。这对开发者意味着什么呢？一个显著的变化体现在 GitHub Copilot 上，它不再仅仅是一个结对程序员，而是进化成了能独立承担任务的同伴程序员，能够处理修复 bug、开发新功能等等更复杂的工作。微软甚至还开源了 GitHub Copilot Chat 的框架，这正好呼应了萨提亚·纳德拉与 OpenAI CEO 山姆·奥特曼的对话。
We're very excited about OpenAI's Codex agent that was just launched on Friday. And I'm thrilled to have Sam Altman join us virtually. Welcome, Sam, to Build.
Thank you. Thank you for having me.
Hey. You know, one of the things I know you've thought a lot about, all these various form factors that developers use for software engineering. Of course, you did the CLI, and now, last week you did the coding agent. You want to talk a little bit, Sam, as sort of the vision you have for how software engineering evolves and actually how developers will use all these various form factors together.
Yeah, so Satya, you and I have been talking about this for a long time. In fact, the very first version of Codex, I think it was all the way back to 2021, one of the very first things we did together in GitHub. And we've been talking about how someday we'd get to like a real agentic coding experience. And it's kind of wild to me that it's finally here. I think this is one of the biggest changes to programming that I've ever seen. But this idea that you now have a real virtual teammate that you can assign work to, that you can say, hey, go off and do some of the stuff you were just doing and increasingly more advanced things, at some point say like, I got a big idea, go off and work for a couple of days and do it. And that you can issue many requests in parallel, that you can be fixing bugs, implementing new features, answering questions about the code. This is like true software engineering task delegation. And I think it'll only get better from here, but this is just a tremendously exciting moment. It integrates very deeply with GitHub. You can give it access to a repo and an environment, and you can get some pretty amazing stuff done.
Yeah, no, it's really exciting to see that. And it's also sort of great to have developers stay in the flow, work with essentially peer programmers, these agents as well as other, people that we collaborate with, and just have the developer process itself and the life cycle get faster. Obviously, you also are working on a lot of models and are very sort of fantastic. In fact, we've had a chance to sort of sim ship a lot of the models you guys have built. Just tell us a little bit about what's sort of coming as far as the model roadmap itself.
The models are already very smart. They will continue to get smarter too. But I think one of the most exciting things is the models will get simpler to use. You won't have so many to pick from. It'll just sort of automatically do the right thing. They'll get much more reliable. You'll be able to trust them for much more. There'll be a lot more features like multimodality and great tool use and integration. It'll be closer to the it just works. I can talk to it. I can do a complicated coding agentic thing. I can rely on it. And I think people are going to be surprised at how fast we're going to make progress in those directions now.
Yeah, I know we're very excited about your model roadmap. And obviously, when you look at ChatGPT, it's the most at-scale, stateful agentic app today that you guys built. And of course, Codex is another sort of agent app that you build. And this conference is all about unpacking so that every developer can, in some sense, build these new agentic apps, that use the model, do their own model scaffolding, go on to even do multi-agent orchestration and so on. Any advice you have as people build out these high-scale production, stateful agentic apps, Sam, based on obviously what you guys have been doing and leading?
I think one of the hardest, most difficult things to manage about this is just the rate of change. if you think about what was possible 2 years ago or 1 year ago or now, and what will be possible in another year or 2 years, sort of planning for this incredible increase in model power and how people are going to build products and software and companies in the kind of near future, and really leaning into the new tools and the sort of new workflows that are possible. Again, we haven't seen many technological shifts like this in history, but every time one has come, like leaning in early and hard has been very rewarded.
No, yeah, and that's absolutely well said, because at some level, one of the things we want to really unpack at this conference is what's that app server that allows you to take the latest new sample that comes and keep moving at that pace, because I think that's the challenge we have as developers building these applications. But it's fantastic. Again, go ahead.
Yeah, I was just going to say, it was amazing to watch over the last few months as we were working on Codex internally. There are always a few people that are the early adopters, and how quickly the people who were just using Codex all day changed their workflow, and just the incredible amount they were able to do relative to someone else was quite interesting.
No, it's fantastic. Thank you so much, Sam. Thanks for the partnership. See you again at Build Again.
奥特曼认为，拥有一个能真正分配工作的虚拟队友是编程领域最大的变革之一。这远不只是帮你写几行代码那么简单。他预测 AI 模型会越来越聪明可靠，功能也会越来越强大，比如支持多模态使用工具等等，用起来也会更方便。但他也指出，最大的挑战在于适应这种飞快的变化，建议大家尽早以及积极地拥抱新工具和新流程，因为回报将是巨大的。而微软开源 Copilot 的框架正是希望携手社区，共同加速这一进化过程。开发者有了更厉害的帮手，但这些智能体需要强大的大脑，也就是 AI 模型。在这方面 Azure AI Foundry 平台也带来了新选择。除了 OpenAI 的最新模型，微软还加入了 XAI 的 Grok， 这就引出了萨提亚与埃隆·马斯克的对话。
Thank you so much, Elon, for being here at Build. I know you started off as an intern at Microsoft. You were a Windows developer, and of course, you're a big PC gamer still. You want to just talk about even your early days with Windows and the kinds of things you built?
Yeah, well, actually it started before Windows with DOS. I had one of the early IBM PCs with MS-DOS, and I think it had like 128K in the beginning, and then it doubled to 256K, which felt like a lot. So I programmed video games in DOS, and then later in Windows. Remember Windows 3.1?
Yeah. No, it's wonderful. I mean, even the last time I chatted with you, you were talking all about everything, the intricacies of Active Directory. And so it's fantastic to have you at our developer conference. Obviously, the exciting thing for us is to be able to launch Grok on Azure. I know you have a deep vision for what AI needs to be, and that's what got you to get this built. It's a family of models that are both response and reasoning models, and you have a very exciting roadmap. You want to just tell us a little bit about sort of your vision, the capability. You're pushing on both capability and efficiency, so maybe you can just talk about a little bit of that.
Sure. So yeah, with Grok, especially with Grok 3.5 that is about to be released, it's trying to reason from first principles, so apply kind of the tools of physics to thinking. So if you're trying to get to fundamental truths, you boil things down to the axiomatic elements that are most likely to be correct, and then you reason up from there, and then you can test your conclusions against those axiomatic elements. And in physics, if you violate conservation of energy or momentum, then you're either going to get a Nobel Prize or you're wrong, and you're almost certainly wrong, basically. So that's really the focus of Grok 3.5 is sort of fundamentals of physics and applying physics tools across all lines of reasoning, and to aspire to truth with minimal error. Like there's always going to be some mistakes that are made, but we aim to get to truth with acknowledged error, but minimize that error over time. And I think that's actually extremely important for AI safety. So I've thought for a long time about AI safety, and my ultimate conclusion is the old maxim that honesty is the best policy. It really is for safety. But I do want to emphasize, we we have and will make mistakes, but we aspire to correct them very quickly. And we are very much looking forward to feedback from the developer community to say, like, what do you need? Where are we wrong? How can we make it better? And to have Grok be something that the developer community is very excited to use, and where they can feel that their feedback is being heard, and Grok is improving and serving their needs.
Yeah, I know it's in some sense, cracking the physics of intelligence is perhaps the real goal for us to be able to use AI at scale. And so it's so good to take that first principles approach that you and your team are taking. And also you're deploying this. I mean, one of the things about sort of what you do is you're doing, unsupervised FSD on one side, you're doing robotics, of course there's Grok, so you're deploying Grok across all of your businesses from SpaceX to Tesla, obviously at X. I would love to even, one of the themes for this developer conference, Elon, is we're building pretty sophisticated AI apps, right? It's not even about any one model. It's about orchestrating multiple models, multiple agents. Just anything that you're seeing in the real world application side, even inside of your own companies, when you think about even a Tesla or a SpaceX, where you put Grok and the other AI models you're building?
Yeah, it's incredibly important for an AI model to be grounded in reality. Reality, I was saying, which is like physics is the law and everything else is a recommendation. Which is, I'm not suggesting people break the laws made by humans. We should generally obey the laws of humans, but I've seen many people break human-made laws, but I have not seen anyone break the laws of physics. So for any given AI, grounding it against reality, and reality, for example, as you mentioned, with the car, it needs to drive safely and correctly. The humanoid robot Optimus needs to perform the task that it's being asked to perform. These are things that are very, very helpful for ensuring that the model is truthful and accurate, because it has to adhere to the laws of physics. So I think that's actually maybe somewhat overlooked, or at least not talked about enough, is that to really be intelligent, it's got to make predictions that are in line with reality, in other words, physics. It's a really fundamental thing, and being able to ground that with cars and robots is very important. We are seeing Grok be very helpful in things like customer service. The AI is infinitely patient and friendly, and you can yell at it, and it's still going to be very nice. So
that's good.
Yeah, so I think in terms of improving the quality of customer service and sort of issue resolution, AI is already Grok is already doing quite a good job of that at SpaceX and Tesla, and we look forward to offering that to other companies.
No, that's fantastic. Really thrilled to get this journey started, getting that developer feedback, and then looking forward to even how they deploy. There's these language models. There's, I think over time we will have this coming together of language models with vision, with action, but to your point, being really grounded on a real world model. And that, I think, is ultimately the goal here. And so thank you so much, Elon, for briefly joining us today. And we're really excited about working with you and getting this into the developers' hands.
Thank you very much. And I can't emphasize enough that we're looking for feedback from you, the developer audience. Tell us what you want, and we'll make it happen. Thank you.
马斯克主要介绍了 Grok 的特点，强调他从第一性原理进行推理，目标是追求真理，并且要勇于承认错误。他甚至将物理学的工具应用于所有推理领域，并特别强调诚实对于 AI 安全至关重要。这提供了一种与众不同的模型思路，非常期待社区的反馈来改进 Grok。此外 Azure AI Foundry 平台还有一个实用功能，你可以一次性预留计算资源，然后在包括 Grok 在内的不同模型间共享使用，这大大提升了开发者实验的灵活性。有了趁手的工具和多样的大脑，这一切的运行都离不开强大的基础设施支持。这就不得不提微软与英伟达的合作，以及萨提亚与黄仁勋的对话了。
Thank you so much, Jensen, for joining yet again for our Build Developer Conference. You were here a couple of years ago, and we had a chance at that time to talk about all the great innovation you were bringing to our Azure and how customers were going to benefit. And in fact, in the last 2 years, you've sort of continued to push the real frontier of innovation. And you and I have talked a lot about how this may be, again, the golden age of both silicon, hardware systems, software systems all coming together. And one of the things that I've really learned so much from you in sort of saying, look, at the end of the day, our joint goal is to be able to deliver more intelligence to the world. In some sense, you can even say it's tokens per dollar per watt, right? That's sort of what ultimately is going to help the world flourish. And so I just wanted to be able to maybe get your perspective on all this, maybe starting, in fact, with the very start of what has been our industry, which is Moore's Law. You've really taken this Moore's Law and put it back on hyperdrive. And maybe you want to speak to, in fact, right behind me is a signed GB200 from you, and we are now just about putting that into massive production. And so I just wanted you to talk a little bit about how this is actually working generation to generation in terms of just the benefits of Moore's Law.
So excited to be here, Satya. In fact, 2 years ago, we had just launched the largest AI supercomputer in the world together on Azure. Right. And then right now, as we speak, we are in full production with Grace Blackwell. We are ramping and scaling and building the largest AI supercomputer in the world in Azure. And so this is just an exciting time, literally 2 years later. Well, during that time, we've innovated across the entire stack. This is the big change in how computing works now. Instead of just the processor running static software, if you will, everything about the stack has changed. And so our processor has changed. Our NVLink has changed so that we can scale up to a much larger compute node. It's liquid cooled. The architecture is FP4 Tensor Core. We now have the ability to connect Grace and Blackwell coherently over a super fast link. Very important in the world of KV caching as we talk about these large agentic model and agentic workloads. And so all of this stuff combined with our new CUDA algorithms and new model technology in your new AI infrastructure on Azure, together, all of that together, 40x speed up over Hopper. 40x speed up over Hopper. That's just an insane speed up in just 2 years.
No, it's just unbelievable. And in fact, that type of compounding of S-curves, right? Your innovation, our innovation coming together, ultimately driving that frontier forward is just unbelievable. But one of the other things you taught me, which I'll always remember, is that speed of light execution between even the two organizations is a way to deliver that, right? There is, in fact, in our fleet, as you can imagine, we have all the generations of NVIDIA and the new generations coming in. And you want to speak to a little bit of what Moore's Law and speed have to do with each other when it comes to driving innovation?
Yeah, this is the insane execution of our two organizations now hyperlinked, if you will. In fact, when technology is moving 40 times per generation, and it's 40 times every 2 years, you really want to upgrade every year. You don't want to wait every 4 years, build out a giant fleet. You want to build out small amounts at every single year. And each year, let's say it's 10 times faster than the last year. And as a result, you cost average, if you will, or inverse to that, performance average up your entire fleet. And so you want to innovate, and you want to integrate new data centers, new computer architectures every year. The complexity, of course, is the work that you and I do is not about building PCs anymore. It's building these giant AI factories. The scale is incredible. The technology is insanely complicated. And for our organizations now to be innovating every single year requires really tight integration. And so that's the challenge, but the benefit's incredible.
Yeah, and I think that point about that physics of the fleet, right, continuously taking advantage of what comes out each year and that compounding of that 40x improvement every 2 years, let's say. And then the fleet itself will be there for 4 years, 5 years, and the benefits of it go all through that period. In fact, talking about that, one of the other things, you mentioned this even in, when you talked about the first point, which is the software. The innovation you're doing in CUDA, some of the system software work that we do end-to-end, the app, we talked a lot about even the new app server for AI that we're doing, even something like even just, when I look at an application and its performance, whether it's latency, COGS, even the smart techniques of prompt caching, plus everything else that happens, just makes a huge difference. But you want to talk about the compounding effects of software that then add to all of what we're doing together?
This is just incredible about computing architectures that are stable, that are programmable, have a rich ecosystem. So meanwhile, while we're sitting here executing from Pascal to Ampere to Hopper to Blackwell to, next generation, all of our software architectures are compatible. As a result, the rich ecosystem of tools and all the developers that are developing on it, they're anxious to develop on it because the install base is so large. They're anxious to develop on it because the ecosystem is so rich. And all of that enables them to invest deeply into enhancing their models and their algorithms and their runtimes and orchestration layers because it affects and benefits the entire fleet. And so while we're sitting here executing new generations of architectures every single year, we still want architecture compatibility. We want the rich ecosystem to be stable so that software developers' investments and all of the AI developers' investments and all your infrastructure customers' investments get to be distributed and amortized across the entire fleet.
Yeah, and in fact, one of the things we're very excited about is given the fleet we now have, we are able to take advantage of these software advances across the entire fleet. And I think that's one of the things that people don't understand, that even the things that were shipped from you multiple years ago benefit from software advances.
That's right.
Continuously.
Hopper. We've been shipping Hoppers to you now for 2 years. Over the course of those 2 years, through new algorithms, let's just say Transformer, let's just say Llama 70B, over the course of the last 2 years, we've improved the performance 40x. Blackwell to Hopper is 40x. Hopper on Hopper has been 40x over the last 2 years. We did that through all kinds of things like in-flight batching and speculative decoding and all kinds of new algorithms that sit underneath the inference engine. And we're willing, and of course, all of the researchers and all the developers, they want to invest in improving the architecture on CUDA because they know the install base is so large. Whatever work that they do will benefit a lot of the fleet, and many users will be able to benefit from it. And so you're willing to dedicate your entire, all of your heart and soul into optimizing the algorithm and the architecture because the install base is so large.
No, that's so well said, because in some sense, the latest GB200 coming up means some of the folks who are doing the cutting edge new training will go there. And at the same time, we're also providing, for example, in Azure Container Service, some of the sort of software gains of the fleet on the GPU fleet so that they can run any agent on it. So that ability for us to be able to flex the fleet for the various different parts of the frontier of latency, COGS, and performance is just fantastic to have.
Yeah, your engineers and ours are at this moment optimizing runtimes on Ampere, A10s, A100s. And the beautiful thing is because of our natural understanding of the importance of preserving, enhancing developer productivity and developer value for the life of the architecture, we support software and we fine-tune software for as long as we shall live. And so
that's right.
And all of that is just, between our two companies, we're dedicated to all the developers.
Yeah, no, that's absolutely. And then the last one I wanted to unpack is another thing. You talk about sort of GPUs is sort of more broader than just one AI workload. It is this accelerated compute vision you've had, quite frankly, for the longest time. But I think that also is a massive benefit to us because that also means we can bring many, many different classes of workloads. That means customers can use this fleet for, of course, the cutting edge AI, but many workloads. But you want to speak a little bit to what happens to utilization and the diversity of workloads that get all accelerated?
One of the benefits of CUDA is that the install base is so large. Another benefit of CUDA is that on the one hand, it's an accelerator architecture. On the other hand, it's fairly general purpose for some of the heaviest workloads. Our two teams are working on accelerating data processing.
That's
accelerating data processing by 20x, 50x. Transcoding video, image processing, models of all kinds, recommender systems, vector search engines. All of those different types of algorithms map wonderfully on top of CUDA. And so with our computer scientists working together, we can accelerate one workload after another workload, one after another workload. And so as this tail, if you will, the long tail of GPUs and all of the frontier models move off to Blackwells and Futures, we leave behind this compute fleet, which is still orders of magnitude faster than general purpose computing that can be used for all these different workloads. And so our job is to make sure that that fleet and that workload, all of the workloads of your data center are fully accelerated. The fleet is fully utilized for the entire life of the fleet.
No, that's fantastic. And so well captures that real essence, right? Ultimately, it's not just tokens, but it's all workloads per dollar per watt. Can we really accelerate them all as we continue to innovate across both the hardware and the software boundaries and really have the compounding effects ultimately show up for our customers? So thank you so much, Jensen, for the partnership. Thanks to everybody at NVIDIA for the amazing work that you all are doing. And it's great to see these two companies that have worked from the very beginning on many of those architectures to come to this point where there is complete new, I would say, emergence of computing that none of us could have ever imagined, but is, I think, going to have a very profound impact. So thank you again.
And Satya, thank you for your partnership and leadership and the alignment between our two organizations to build the most advanced infrastructure in the world, the most advanced AI factories in the world is really a delight. And here we are in just 2 years' time, AI has transformed so profoundly and it's just so exciting. This is the best of times and the best of times are yet to come.
Thank you so much.
这场对话的核心在于如何高效地为世界提供更多智能。他们关注一个关键指标：每美元每瓦特能产生的 token 数量。黄仁勋披露了一个惊人的数字，相较于2年前的 Harper 架构，通过软硬件协同创新，结合新的 CUDA 算法、模型技术以及 Azure 的优化 ，AI 计算能力提升了足足40倍。40倍。这个数量级的飞跃，才使得大规模复杂的 Agentic Web 构想变得越来越现实。黄仁勋还强调了 CUDA 生态系统的稳定性与通用性，确保软件优化能够跨代延续，并加速数据处理、视频转码等等多种工作负载。值得一提的是 ，Azure 也是第一个大规模部署英伟达最新 GB200的云平台，足见双方合作的深度。OK， 我们梳理一下，开发者工具在进化 ，AI 模型选择更多样，底层算力在爆炸式增长。那么这一切汇聚而成的 Agentic Web， 对于我们普通用户来说，最直观的改变会是什么呢？对我而言，最直观的感受可能是 AI 将从一个你需要主动去使用的工具，转变为一个更能主动来帮助你的协作者。想象一下 ，Microsoft 365 Copilot 中可能会出现研究员、分析师这样的智能体，主动帮你完成研究和分析工作。或者你可以用 Copilot Studio 构建一个智能体，自动处理复杂的流程，比如新员工入职、响应项目招标书等等。还有像 MCP 这样的协议，能让不同的智能体互相沟通、协同工作。NLWeb 技术则能让智能体更容易理解和使用我们现有的网站，盘活海量网络资源。甚至微软还推出了 Foundry Local， 可以将 AI 能力直接部署到个人电脑上， 在本地开发运行 AI 应用，访问本地数据，兼顾强大功能与隐私保护。所以，关键在于我们可能真的需要开始适应，并学习如何与这些日益强大的智能体协同工作。今天我们通过了解萨提亚与奥特曼关于智能进化，与马斯克关于模型多样化，以及与黄仁勋关于基础设施飞跃的这3场对话，恰好勾勒出塑造 Agentic Web 未来的几股关键力量。我前面的视频中提到，谷歌 AlphaEvolve 迈出了 AI 递归式自我改进的步伐。谷歌在 AI 领域拥有强大的技术栈，从数据到芯片到 AI 模型等等。谷歌的顶尖科学家 Jeff Dean 近期在红杉资本 AI Ascent 2025的演讲中提到 ，AI 已经参与到硬件设计。DeepMind 最近发布的论文中也提到了 AI 通过递归式自我改进，不断提升其 AI 的全技术栈性能。微软 CEO 萨提亚在 build 2025上的连线，是不是有点像联合大家对抗谷歌的 AI 呢？实际上，这是微软的多元化 AI 战略的体现。微软明确表示，正在测试和整合多个 AI 模型，比如 xAI 的 Grok、Meta 的 Llama Anthropic 的 Claude DeepSeek 的 R1 等等，以减少对 OpenAI 的依赖。这种多元化的策略被认为是应对谷歌等竞争对手的手段之一。最后提一下，微软展示的一个案例 ，AI 智能体被用于发现数据中心的新型冷却材料，这表明 AI 已经开始涉足科学探索。那么，如果现在你可以组建一个由不同专业领域的 AI 智能体构成的虚拟团队，你会让他们去攻克哪个一直让你头疼的复杂问题，或者去探索哪个你一直特别好奇的未知领域呢？好的，今天的视频我们就先聊到这里。如果你喜欢今天的节目，别忘了点赞、分享，并订阅我的频道，及时获取科技资讯和深度解析。感谢观看，我们下期再见。